Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to cover in this lesson is the first of several lessons on file I/O, or file input and output. So what we're going to do in this lesson is we're going to do the very basic file input, file output I should call it, because we're outputting to a file. And what we're going to do is we're just literally going to print the words hello world into a text file so that you can see that in operation. So the first thing I have to do is I have to make a pointer to a file, and I do that by using the following. Okay, now the letters FP are literally stand for file pointer, but we could call that anything we wanted. So I'm going to call it FP, but that there's nothing special about that. And I know some people were wondering, was there something special about the words, the letters PTR that we often use as well? Again, those are just text that I've given it to suggest that it's a pointer, so don't feel that they're important. But the capital lettered thing here, file, for a file pointer, that is, it's not quite a keyword, but it is something that the compiler understands. So that is how you would write a file of this type. So presumably, and I haven't actually seen it, but presumably that is a typedef that's been written somewhere for a file pointer, and it lets us know then that it's a file pointer that we're dealing with. So what we do in order to open it is we say FP is assigned fopen. So you can see all these file functions have F's in front of them, and I can give the name of a file here. Now, if you have a string constant, such as a character array or something, with that written in it, you can also just put in the variable as well, the array variable. But I'm writing it directly in for the moment. Now, I want to open this file for writing, and so for that reason, I put in a W. Okay. Now, one of the problems that can occur is that what that function does, the file open function or fopen function, what it does is it tries to open the file output.txt, and because we haven't given a full directory structure for where it is, it will try and open it in the current directory that this C file is executing from. Now, if that file does not exist and it has the permission to write to that directory, in other words, if it's not a read-only directory and there's enough memory space on the disk, then at that point it will create the output.txt file, and so that's what will happen the first time we run this. If the file already exists, then it will just open it for writing. However, there is one thing that could occur, which is that if the file already exists but it's already opened by somebody else, then this C file or this executable cannot open it to make modifications to it, and so it will not be able to return a pointer to it. So what occurs when everything works right is that FP becomes the address of where that file has been opened in RAM. But if it can't open it for whatever reason, that FP will be set to null or to 0. So the only way of us knowing that that is occurring is to check what has occurred. So we always check this. This is important that we do it. It's not just some little thing that I throw in there for no good reason. So we want to check, is FP equal to null, and make sure that's a double equals there and not an assignment, a single equals, because I've seen somebody do that recently, and it meant that it actually set the pointer to null rather than checking if it was equal to null, which destroyed what he was trying to do. Now, what we do at this point is we like to tell the user who's operating it that there was some problem. Okay, so what I'm saying is that file couldn't be opened for some reason. We don't quite know the reason why, because there could be any of several different reasons. We need to do a system pause at that point, or otherwise what will happen is the program will end without us actually doing anything. So, and we need to return from the program at that stage. There's no point in continuing this program any further if we can't open the file. Okay, so we need to remove from it. Now you'll notice that what may seem very rare, I'm saying return 1 rather than return 0. We're used to return 0 being at the bottom, which says that everything ran fine. If things don't run fine, we usually return something other than 0. Now, I'm doing this as a matter of course. The fact is that because I'm running this program myself, there's nobody to return that to. So these numbers are just going back to nobody in particular. But if some other system was running these files as a subset of its own system, then it may want to see what the result that comes back is, and therefore we would write these different error numbers to suggest it either ran fine or something else went wrong. Okay, so we just need to put that in there in order to make sure that that the file opened properly. Now we can actually write something to the file. Now this should be quite familiar to you. It's a printf, but it has f written in front of it because it's a file printf. And we always put the pointer to the file that we want to write to as the first argument to this. After that, it acts very much like your ordinary printf statement. And I'll put in some exclamation marks. Now, just before I finish, what I should also do is I should close the file again, because if I don't, there's a chance that the operating system will not realize that we've finished with it, and it will leave it in our care, and we can no longer make a modification to it, and the file is somewhat lost. So it's always a good idea to write fclose at the bottom. It's kind of like cleaning up after yourself. And finally, what we do is we set the pointer to 0 so that it's no longer pointing at it as well. That's not quite as important in a small file like this, where that pointer was never going to be used again and the thing has finished. But if you're in some larger program where you open and close files all the time, it's important that you don't maintain a pointer to a file that is now closed, and so you should always go and set that pointer to either null or to 0. Okay. So that's pretty much it, and you'll find when this runs that not a whole lot happens. However, what I'm going to try and do is I'm going to try and open the directory that it's in, and I'm in C201, and I've put it in this directory file.io. So we can see there that it is only file.io, the C file that's in there. Now what will occur when I run this is, firstly, it will make an executable file, so we expect to see one called file.io appearing there. And secondly, what it will do is it will create the text file as well. Okay, so I'm going to try and have both of these open side by side, so you just see it. So click this to go, and you can see the two files have been created here. One called file.io, that's the application, and output, which is the text document that I've just done, that I've just created with the program. There were no printfs in my program, so it literally just finishes with press any key to continue from the system pause, or if you're using the new version of dev.c, I think that happens anyway, whether you use system pause or not. So we return to get out of there. That's a good idea to do, because that then releases, it means that we've gone past this point and we've released the file. And now we have closed it already anyway at that point, but it's usually best just to close off our program as well. And we can then open the document, and the document says hello world. Okay. Now if you're unconvinced by this, what I'm going to do is I'm just going to delete that document once more, and I'm going to run it again so that you see. So you should only see one file created this time, and that's the output.txt. And you can see it there, it's appeared on the right hand side of the screen. Okay. And what I can do is just change this to my name and once again we can run that, and all you should see change is that the timing on the thing will change now, because I haven't waited a minute. It's still saying at 26 minutes past 8, but if I open it up, now it has hello world, my name is Sean. Now what I'm going to do this time is I'm going to leave it open. I'm going to leave that open and I'll run this, and that has allowed me to do it anyway, so the problem hasn't occurred while it's open on this machine, but you may find it happens for you. I know it certainly has happened to me with previous programs that I've done. So I'm just going to see if maybe if I make a modification, it might happen to me. Now this can be all be down to the sophistication of the operating system, as to whether there's an issue or not. Okay, so that's not given a problem. I'll see if it happens in some of the later files, and certainly, well, actually, we can see there it hasn't made a modification to it, but if I open it up again, it has made that modification. Okay, so it hasn't caused this issue to occur because I had it open. I expected that to happen because it does happen to me on other systems, but you can see yourself, try it on your own system and see if it occurs, or see if it's just related to the operating system that you're on. Okay, so I'm going to leave it at that for this one, and I'll be coming back in the next one to make a different type of file that we're going to open, one that we're going to handle in Excel rather than a text file.